So now we start. Thank you everyone for waiting, and welcome Oriol and Marc. It's a pleasure to have you here. So today we will have a demo workshop of industrial IoT. It will go from legacy to digital factory, and we will use open source tools. So before we start, I would like to tell you a little bit more about SIGRAD. And I would like to ask you a question. So how many of you are alumni? Maybe you can give some answers on the chat. So SIGRAD is an institution of innovation with more than 20 years of experience in the field of online education, specifically for professionals. So we aim to train and empower individuals and organizations to be the catalyzers of change and transformation in the industries. And in concrete here, about IoT. So being part of SIGRAD means that you will find a network of more than 2,000 students each year coming from more than 100 nationalities. You also get mentoring from professors like we have today, Marc Pous and oriolrius. And you will also learn by doing. That means that you will have workshops, you will have use cases, presentations, and much more. And last but not least, there's also a possibility to get to know other peers, students and professors and externals in our student weeks that we organize each year. And this year actually is going to be face-to-face. We're going to have one in Barcelona and one in Sao Paulo. So I'd also like to let you know that if you stay tuned until the very end of this workshop, you will get a surprise, which we'll talk more about it later. So now I give the floor to Oriol and Marc Pous. So feel free to share and you can start the workshop.
Okay, very good. Marta, please also stop sharing you.
Thank you, Marta.
Then let me just share a portion
there you
of
go.
the screen.
So, yeah, hello, everyone. Welcome to this workshop. So today, Oriol and me, we are going to do something super dangerous. We didn't pray to the gods of the demos, right? Because I convinced Oriol, I think it's the first time that he doesn't have everything 100% of the workshop ready. We want to do things live. Okay, so maybe Oriol, let's explain what we are going to do.
I'm smiling because you are completely right, Marc. So
yeah, so today what we want to do, actually, yeah, well, maybe you can explain what you have on your table, and then yeah, we explain what we.
Yeah, let me. Can you hear me? Okay. Yeah, because I didn't have the chance to check my mic but before, so I hope everyone can hear me. Okay. Yeah.
Yeah.
Okay, then what you can see here, it's not a picture, it's a camera. Hello. Okay, then this is in my table just now next to me, and because there are some stuff on top of the table, I took a picture and I'm going to explain what I have on the table. But before that, let me introduce why that makes sense. Okay, the goal today is to introduce to all of you one strategy, or maybe the most used strategy for connecting legacy instruments in a factory, in the facilities of the factory, to connect them to the IoT ecosystem. If you are not technical people, you have to know that one of the most used protocols for talking with especially legacy machines, and also, let me say, current machines. I mean, there are a lot of hardware around which talks a protocol called Modbus. I'm going to write it down here for you. It's Modbus, and I'm going to zoom in.
By the way, we didn't mention that, Oriol, but
yes.
Feel free to ask questions, questions on the chat. So feel free to interrupt us.
Yeah, and it will be by far much more interesting and useful for all of you. So don't worry, I'm just opening the chat. Yeah, Sinterrel, thank you for answering Modbus. Yeah, this is the idea. So we are going to explain how to set up from scratch a gateway for gathering data from some devices which talks that protocol called Modbus. Okay, then we are going to translate the protocol and to save the data that we read in a database called Influx Db. Let me write it down just for start familiarizing. And the database that we are going to use is called Influx Db. Okay, it's a time series database, especially useful for playing with time series, of course. And then, apart from that, we are going to use Graphana just for monitoring, for creating a dashboard which shows that information. For all that gathering, for getting that data, we're going to use a flow programming system called NodeRED. It's especially, when I say use it in a lot of environments of IoT. Okay, so we encourage you to spend as much time as you can for getting some experience on NodeRED. And we are not going to push the data directly to the database. We are going to use an MQTT broker, which is not going to be super useful in this example, but it's just for showing you how important are the events in an IoT solution. Okay, we are going to convert data that we pull from physical devices to events available for a complete industrial IoT ecosystem. As I said, I have a setup.
Uriol is simulating on his table a factory. Yes. Actually, he has all the hardware needed.
Yeah. To be a little bit more precise, Mark, not just a possible electrical parts that can be available in any factory. Okay. Mm-hmm. I assume that you can see my mouse. Is this correct or not? Yes. Okay. Thank you.
Yes.
I'm going to use my drawing table for marking some stuff in real time, and I think it's going to be by far more useful. For example, here we have the Iot Gateway. Oh, this is very thin. Let me change it for something bigger. Okay, so here we have an Iot Gateway. You can read it here. Okay, thanks to that Iot Gateway, where we are going to set up all that stuff that I previously introduced, we are going to use an Ethernet connection directly to that stuff, that device, which is a Schneider device, which works as a Modbus master with different entry inputs and outputs and some other stuff. Now I'm going to say a little bit more about this device. And here we have a circuit breaker. Let me zoom in just for allowing you to see it perfectly. Yeah, this is a circuit breaker, that one. Okay. And then that circuit breaker has two attached devices. One of them is that one, which allows us to read, pay attention, thanks to this, we can read what's the position of the circuit breaker, if it is open or closed. Okay. And we have another attached device, which is this one called power tag, which allows us to read, for example, the voltage, the current, and the power, for example, of the current that we pass through it. That Acti9 device from Schneider, as I said before, has different 1, 2, 3, 4, 5, 6, 7, and 8 digital input and outputs. Apart from that, it has the possibility to use different Modbus TCP slaves that can be connected here. And yeah, at the end of the day, it is something that can be installed in your next to your electrical parts for monitoring your electrical systems. And thanks to that, you can monitor using Modbus the status of your electrical systems. This gateway, from one side, it is connected to the company, thanks to this Ethernet connection, and to these parts to that Ethernet connection. Then I'm spending a lot of time to explain something very simple, but I have to emphasize something before jumping to the gateway where I'm going to give the word to Marc. It's very important. You have to know that Modbus, okay? Modbus, it's a protocol which allows us to directly access the memory, okay? The memory of whatever device which uses Modbus. Okay, then we can have access, read and write access to the memory of a device, which is something that can be super dangerous. Okay, because maybe if we have a robot, for example, and we can access in a write mode to the memory, maybe we can actionate, maybe we can set, okay, some dangerous movements of the robot. Okay, so take care with Modbus, because it is a protocol that comes from a long time ago where we used RTU, so it is a serial protocol for exchanging data directly with the memory of the legacy devices. Okay, and what Modbus does, for example, we have Modbus RTU, which is the legacy one, and Modbus TCP, which is also legacy, but which allows us to move the data on top of TCP IP network. Sin is asking, that's an ACT9 IO and it is Modbus master. Yes, yes, Sin, exactly that. Okay, so ACT9 plays as a Modbus master where I can access, where I can use directly, or where I can access directly to the memory of ACT9. And thanks to that, I can monitor the electrical parts. Then, not much more from my side, just saying that this is going to be the gateway of our network to internet. And in last minute, if we have enough time, we are going to connect that edge device, which is that IoT gateway with a lot of stuff inside. We're going to push that data or to publish that data to data cake. Okay.
Exactly.
This is
just to clarify this part, Uriol. So we are going to do everything on the edge. So we are going to do edge computing at the beginning. Yes. So Uriol already introduced all the services that we are going to run on a device like this that maybe now we can introduce. Exactly. And then finally, we are going to show how this data as well can go outside if we have time.
Yes. Marc, maybe it's good from your side to introduce what we are going to have inside the IoT gateway.
Sure. Yeah, that sounds good. So I have here as well an IoT gateway. I have one on my table. You're going to see now that Uriol and me, we created a fleet of industrial IoT gateways. So actually, just as well to give a little bit more context. So what we are going to show today, it's how to digitalize an industrial, industrial equipments like the ones that Uriol shared, but that can be other ones. Usually running Modbus, but you're going to see that this is very flexible. And we are going to do that with open source technologies. And basically, we are going to do that. At the moment, this project only worked with x86 machines or AMD 64 type of hardware. So we are working to make this compatible as well with Raspberry Pi, so ARM devices, 64 bits. But yeah, let's see if we can make it happen. But at the moment, if you have an x86 device on your table right now, you can replicate what we are going to do in some minutes. Okay, what runs inside these devices? Basically, we are running Balena OS. That means that everything that runs on this device runs on a container. So we have containers and services. We have NodeRED, Influx, MQTT broker, and Graphana running as containers. So just to give a little bit more context of what's Balena, if you know what is an update, an update over the air. So if you get an update of your Windows operating system or an update of an application running on your mobile phone, this is what Balena does, but it do it for embedded devices. Okay, so you have to imagine, well, actually, the IoT devices as well, the code running on IoT devices is not perpetual, or it's not static, right? So there are bugs, there are improvements, new features that you need to run on the devices. So Balena just enable developers and companies just to update the software running on devices in a really simple way. So this is why we decided to run Balena, because if not, the alternative was to install another Linux operating system and start installing packages and so on and so on. So actually this solution for this Iot Gateway, basically in one click, we are gonna allow you to have everything running and automatically configure to make it run and have NodeRED available. Okay. What else I'm missing?
Yeah, Mark, maybe another thing which is remarkable is that thanks to Balena, we are going to have the chance to deploy not only once we can deploy that for a fleet. Maybe we have 10 devices around in different worldwide places.
Exactly.
And just with one click, we deploy all the stack to all those devices with just one click.
Indeed, yeah. If you have a factory, well, if you have multiple factories or multiple installations all around the world running these type of devices, so with Balena you can manage them automatically, or manage the software running on all of them automatically. You can have an SSH terminal as well to all of them, and well, it's very handy for this type of use cases to just reduce the friction of managing all of these devices on the fleet.
Mm-hmm. Yeah. Okay, then go.
I think we are good,
to the
right?
solution. Yeah. Okay. Do you want to? Oh, yeah. There is a question from Sin.
Oh, sure.
And another one from Cecilia. Could you write it down, please? Okay. Balena is.
Yeah. Well, I think Sean already wrote down before below you, Cecilia, as well.
Okay.
So you can go actually to balena.io. Actually, what we are going to do, you can run it for free on the balena.io freemium account. You can run up to 10 devices. So imagine if you have a 8 factories, you can run this for free. But yeah, it's maybe Uriol, let's start with Balena Hub to show the application that we are going to run here.
Yeah, you have the control mark. You can move on.
Oh, okay, yeah. Well, no, I was about to answer Sean's question about Balena is orchestrating the containers. Yeah, it is, and handling authentication and reverse proxy. Not sure about the reverse proxy, Uriol. Maybe you can help here about if
handling authentication and reverse proxy or ingress. Yes. It has. For example, let me show you. Here we are in a fleet where we have 2 devices, the Marc device and Uriol device.
Uriol, can you give me access to your desktop, please?
Yes, you already have it. Huh? Just move the mouse. Notice it?
Yeah, but I cannot click on your. Okay, no.
Yes,
maybe I clicked many times. Sorry.
Yeah, the idea while you are accessing, the idea, Sin, it is that. What you moved?
Yeah, there is a bit of.
Yes,
sorry.
Just a second. Take care with a keyboard, Mark, because the keys are not the same. Okay, then the idea it is, yes, for authentication and reverse control, when you have a device deployed, you can say to that device that you want to access remotely, and it acts like a reverse proxy. Okay, so you can manage in a centralized way all the devices that you have around. Okay, good thing.
Okay, I just pasted on the chat what you are seeing. So this is, we just released this application, this industrial Iot Gateway running NodeRED for x86 devices. Okay, and basically, if you want to run this, well, actually the source code, it's here. So there is a GitHub repo. Not sure how to, yeah. So basically, in my GitHub repo, you can have everything, and basically, yeah, if you open the Docker Compose, you're gonna see. I'm not sure how the people if it's expert on containers or not, but we can see that we are running NodeRED, Influx Db from the Docker Hub image, Graphana as well from the Docker Hub image, and MQTT, Eclipse Mosquito broker.
At the end is what we prepared for the session today with Marc. Okay,
Indeed.
We created that project and we shared that project directly to Balena Hub for allowing all of you to deploy the same project that we created in your premises.
Actually, if you click fork this fleet, you're going to go to Belina. Well, yeah, I can do it. And then I can cancel. So if you don't have an account, that's not a problem. You just sign up, and then the system will ask you if you want to deploy these on a fleet. You just say yes, and you do it. Okay, I'm going to cancel here because we already did for the sake of time. And we created this, this fleet called Iot Gateway NodeRED. I'm trying to click. And then we have two devices, actually. If it can click.
Yeah. No, it was me, Mark, sorry.
Okay, no problem. Actually, you can see that it's not, well, we are not in, I'm based in Barcelona, Oriol is not based in Barcelona. So you can see that we have a fleet of two devices that maybe this is a configuration of a company having two installations nearby. And these two devices, right, are managed here on Belina. So I can get into the Oriol's gateway right now, and we can see first the services running on this, as Oriol mentioned before. So there is NodeRED, then TTP broker, Influx Db, and Graphana. And we can see here the logs, and we have a terminal to access over SSH to the devices, to the device.
Important thing to remind about that, all that we prepared for the session is just for demo purposes, okay? So don't deploy that on, let me say, on production, okay? If you have to do that, please ask us before, because there are a lot of small details that we didn't set up because we didn't have enough time for preparing the session, okay? But,
well, and it's not only about the time, Oriol, it's about that every network, every installation has its own things, right? So you cannot, there is no silver bullet, right, on this.
Yes. No, but by the way, what we had or what we prepared has a lot of value. But for example, we didn't deploy, let me say, the proper data storages and etc. So not all the stuff that we prepared is persistent, for example. Okay, indeed. It is for demo purposes. Okay, what's the meaning of that? What we have in the database, if we restart, it is removed. Okay.
And actually, if you would like to add a new container, just deploying a new container, all the fleet would automatically be updated. Well, just let's give a brief explanation of what you need to do if you want to add a device here, as this is an x86 device. So basically, just go to click Add Device. Then you have to, so next step, if you want to add a device on this fleet, it's you have to download the Belina OS image, as mentioned. So Belina OS is an open source Linux operating system made especially for single board computers and IoT devices. And basically the particularity of Belina OS is that only runs containers. Okay, so you have to download
mostly Belina by itself, it's a container. Okay, there's a few things which are not a container inside Belina.
Actually, what I would recommend if you want to test is just to download the development image of the operating system. And if you have an x86 device and it's connected over Ethernet, that's okay. If you have Wi-Fi, just introduce your Wi-Fi credentials here. And then the operating system image that you will download here will have the Wi-Fi credentials automatically set up. So it will automatically be connected to your network. And just click Flash or just download the Belina OS and flash a USB drive. Then, well, if you already boot an x86 device with a USB drive, probably you already know that you need to put the USB drive with the operating system image, get into the BIOS, and say to the BIOS that you need to you want to boot first time from USB, and then once the image it's already installed on the device, just boot again without the USB and start from the hard disk. If I'm not wrong. But don't know if we have a question from Kevin who raised his hand. I don't know, Kevin, if you can write it down, just for the sake of time and. utility. Okay. So Uriol.
Yeah.
What's next?
Then we assume, no, after that, Mark, we have the operating system or the image of the operating system. It is deployed to the device. Now we have the Balena OS boot, and automatically all the containers are automatically delivered and started. So as we noticed when we accessed, for example, to the Uriol device, just for the resources, let me close that stuff because we have the stuff in different, the same stuff in different tabs. And then,
sorry for that.
This here is how it looks like. For example, just because I clicked to Uriol, I can see which is the version of the operating system deployed and which is the version. You can see here current release and target release. Usually it has to be the same. It means nothing is pending to deploy. Okay. And what's the meaning of the current release and target release? At the end, which are the containers that you want to deploy here? Okay.
Yeah, usually this is used for companies or developers who want to test different releases on devices. So basically, for example, let's imagine that you have a fleet of all your devices on production are on your factories, but then you have on your table you are developing a new version. So that device belongs to the fleet, but you ping all your production devices with a release, and then your development machine has like the latest release on it, and when it works, you deploy it to the other devices. Yeah.
Then notice that now I'm using Balena Cloud, so I'm running I'm playing in a cloud infrastructure, so I'm not directly connected to the device. Okay, I'm using an application which is maybe it's in the States, Mark.
Yeah, indeed. Yeah, it's going to be
then
redundant very soon, but right now it's on AWS States.
For example, if I want to access the terminal of that machine or my machine, which is next to me, I'm going to say, for example, I want to connect to the host operative system and just say start. And then it is connecting. My device is connecting to the States. And now I'm connecting to the UI that you can see here. And here it is my interactive shell. No, for example, I can ping, I don't know, for example, the Google DNS.
Yeah, you have to think that, maybe I have devices on the roof of my building, so I cannot go there and connect over USB. So, I mean, this is handy enough. Having said that, you can SSH all the containers and the host OS of the device. Something that is very clear on Balena is that you cannot install anything on host OS. Everything must run on containers. So I think I repeated this 3 times already, but this is very important.
It means that if you are not familiar with containers or specifically with Docker, and you want to play with Balena, then first spend some time understanding the basics of containers, because in the other way, it's going to be a nightmare to move around of Balena. And Balena is super useful, super powerful, but you have to have some basics. Okay, it's not for, I mean, you have to understand what's really the meaning of a container, how the container plays with the network, how the container plays with the storage, etc. Okay. For not spending so much time with Balena, because we have a lot of pending stuff to do this afternoon, notice that now I am inside the container with NodeRED, just for showing you how easy it is, not only to connect to the machine, also connect to the container that I have remotely. Okay, maybe it's time to jump to the applications, no, Mark?
Just last comment that you mentioned that this is running on Balena Cloud, which is like after 10 devices. So 10 devices are free, but if you want to run open source on your on premise, we have as well Open Balena, which is completely exactly the same, but just running on common, so on CLI. So you can deploy actually same features on an open source solution as well. Okay, let's go to NodeRED.
Very good. Then jump to the NodeRED. Here we have a simple simple flow that we already created in NodeRED. I'm going to explain what it does and how it plays with the scenario that we have. Okay, so the idea it is, let me go just a second to OneNote. First of all, we are going to play with IDF plus SD24. Remember what it does. It is, let me say, read or move the position, okay, of that small thing to open or close, depending on if your circuit breaker, it is open or closed. Then, thanks to that, now it is open. Okay, open means that there is no current crossing the circuit breaker. So, for example, here I put some LEDs that are off because it's open. And here I have a fan, which is already connected here, and it is stopped because it's open. Okay, then how it's going to play? As I said, I can access to all the stuff thanks to Modbus. Then here it is the manual of Acti9 SmartLink SIB, which is exactly the device that we have on the table. And just I can go and say, where are, for example, models, address tables. No, it was, we said SDF, how it was called. Sorry, my memory is completely exhausted today. What was exactly the name? Okay, we have some address tables for knowing, for discovering which are the memory positions which has the data that we want to set. Okay, and then generating IOF SD. This is data. I think it is 167. Just, yeah. Setting up Modbus communication gateway function, Modbus master principle. And if we jump to monitoring and control them, Modbus registers table. Okay. Here we have an explanation of what's exactly or what are the information in the memory of the device with which we want to play. IOF plus SD21 is the one that uses for reading that position. And to be more precise, that memory position, which is, it has just one bit, which indicates if it's open or closed. Then here it is the flow. Here we drag it in the left side, in the left panel, we have some different functionalities that we can drag to the canvas that we have in the middle. This is NodeRED, and later we create a flow of information or flow of data that we can modify on the fly. The node that I dragged here is a Modbus. You can see here Modbus read node.
And just as a context, to have these nodes available on NodeRED, you have to install a package on your notebook. Maybe we can introduce that, how to do that.
Yeah, just
it's not automatic configure. So you go to manage palette, exactly, click here, and then you go to install.
Yeah, here you have the list of the already installed packages.
But yeah, you go to install and just search Modbus. It's already installed. You will need as well Influx Db. So you just search here Influx Db, and you will need another one, right?
Yeah, Influx Db. Sorry, Influx Db.
Yeah.
Yeah.
The second one.
By the way, they are
here.
All of them are here.
Exactly.
Influx Db, Modbus. No,
well,
that one, not that one. Buffer parser.
Buffer parser, yeah.
Okay.
Correct.
Buffer parser is going to be used in another flow that I'm going to create on the fly. This is just the simple one. Okay. I said that the register that we have to read, it is 14,200. Okay. It is a reading holding register. I just want to read one bit. In this case, it's 1 byte what we read. We cannot read less than a byte, but it's going to be enough because the first bit of the byte is going to be the information that we want. And we indicate that we want to read that every 5 seconds, okay, which is the polling interval that we want to use. Here, when it says server, it's the Acti9 configuration. Okay, here it's an arbitrary name. We're going to use a TCP protocol. This is the IP address of the Modbus master, the TCP port of the Modbus master, the unit ID that we have to use for accessing the data of the Acti9, which is always 255. And yeah, some other stuff that it can be left by default. I don't want to take so long for
just to have this on our brains to remember, Oriol. I would love before the end of the workshop that you can talk a little bit about security, on TCP networks and industries later. Let's finish this and maybe let's go there.
Then, as you can notice here, it says active 5 seconds, which is the interval. So everything it seems runs okay. And here we have a Modbus response, which is another node that dumps. Let me zoom in a little bit. That dumps the data that we have received. We have received a number 2, and we have received an hexadecimal data, which is 0x00, 0x02, which is binary. Okay. Then with a few lines of JavaScript, we parse the data that we receive and we compare. If we receive a number 3, it means the circuit is closed. In the other case, the circuit is open. Then we put there, here it comes a number 2 or a number 3. The information is parsed. It is just for debugging purposes, and we can see that it is open. Okay. And here we see the flux, which is published in MQTT. What is MQTT? MQTT broker that we defined previously is the events center of your industrial IoT ecosystem. So the idea in MQTT broker inside the factory is to use it as a namespace. Okay. At the end is the place of the factory where you can find all the data in real time of the essential devices that you have around in the factory. For example, in this case, of course, we cannot spend 30 minutes explaining the basics of MQTT. The ones which are studying in the master, they have the proper modules where we explain and we define what are the properties and the functionalities of MQTT. MQTT is one of the most important protocols of the industrial IoT nowadays. Okay, but just for jumping to what we were doing, this is the place inside the broker where we are going to publish the status of that IC69, 60N. Sorry.
Just to give a bit of more context, so MQTT it's a communication protocol. It's a publish, subscribe. So these are the only 2 actions that you can do. Well, yeah, you can. I don't know if you can do more now, but basically, we have a broker. We have a container actually, running on the device that actually will be subscribed to messages that have a topic, or will publish topics. So you are doing broadcast actually. Anything, any device, any broker can be subscribed to topics or can publish to other topics.
Yeah, it's a way to deliver information in real time to different places without having to know which are those places. Mm-hmm. It's exactly like the newspaper is delivered to your door every morning. Okay, just subscribe to the newspaper. They publish a lot of newspaper every night. And magically it appears to your mailbox every morning. Okay, then there is someone doing the magic, of course. In this case, in our case, it is MQTT. Okay, then thanks to that, as I said, we can read the status. So remember, here we have in real time what is happening. Remember, it is on. Now I'm going to move. Here you can see my hand. I just moved it. You can see the fan and the lights. Okay, everything is now it's closed. If I go back here, remember every 5 seconds this is read And now that open that I had here, it moved to a closed. Okay. Remember here in the buffer we had a 0. Sorry, in the data we had a 2, and in the buffer we had 0, 2, 0, 0, 0, 2, and now we have 0, 0, 0, 3. Okay. So we are monitoring thanks to Modbus. Okay, that stuff. Let me just stop it. Okay, you can see my hand, I hope.
Probably it's cold there with a,
yeah,
with a fan, right?
It's a little bit cold. It's not hot enough for turning on the fan now. Okay, but I had to put something. Okay, then you can notice now it's open again. Okay.
And the register is 02.
Yeah, we can do something, just moving from 5 seconds to, for example, to 5 hours. Okay, so only every 5 hours, we are going to read the status of the NodeRED. So, sorry, the status of Modbus. Sorry. Now it is open. Okay, let me click here. Then it says it's open. Perfect. Nothing changed. Now I'm going to go to move it again. Okay. Then I go back here. You notice it's not changing because it is not going to read until 5 hours. Okay. But if I click here, I force the reading. Then you can see just in less than a second, you can read that. Okay, this is quite useful, especially when you are debugging. Let me stop that. Oh, it's quite useful when you are at the very beginning, because if you say that you want to read every 5 seconds, it could be a nightmare for debugging. Okay, because every 5 seconds you have something, and maybe your code is not ready for testing. Then let me follow.
So what do you do with the data here?
Yeah.
What's the latest? So if you go to the pulling data tab, what's this status? Is this an MQTT output?
Yes, exactly. This is MQTT publish. So as you said, an MQTT output. Then everything is going to be published to the MQTT broker. And here I have another flow. What is going to happen here is I'm waiting for some events. Okay, especially the events which inform about the status of that circuit breaker.
So this is a subscription on the MQTT broker, no, to this topic, which is actually no, and the other tab we had a publisher.
Yes,
so,
correct.
Okay, fantastic.
Correct. Then, thanks to that, when something changes, it's going to enter from here. I'm going to manipulate the payload. Okay, if it says it's closed, I'm going to say I want to save to the database a number 1. In the other case, I want to save to the database a number 0. Okay, you can notice how I modify the flux of the data, the payload at the end. Okay, and then here I have another node. Another node. Yeah. Okay. Siren. Understand what you say. Just give me a minute. Here I have how we are going to push the information to the database. Here it is the server
container.
Yeah, exactly. Here it is the information of the container. Okay, the name of the database, the username that we are going to use for connecting to the database, and what's the measurement collection of readings that we want to store that data. Measurements, it's like a table in a relational database. Say quotes, okay, it's not exactly the same, but the idea is similar. Okay, so databases in time series database are collections, or sorry, measurements. Then in this case, we are going to use a measurement called status, which stores the status of IC69 status. Then for shortly explaining what's the meaning of what is MQTT. I need maybe at least 30 minutes for properly explaining how MQTT works and how to use MQTT properly. Okay, so I'm just going to draw in real time in a simple way what we are doing here for understanding what is MQTT. Okay, then here we have a Modbus device. Okay, thanks to NodeRED, we get the status of that circuit breaker. Then what we do, it is just publish in a topic, which is going to be called, just for being short, okay? That topic is going to be called status, okay? And this is going to be published in an MQTT broker. And now I don't want to worry about anything else, okay? I don't have to worry about anything else because I just published the event to the MQTT broker. And then from that moment, any application of the factory which is going to be interested on doing something with that data can subscribe, can be alerted when any change happens, okay? And it's going to work like a trigger for doing something. So here we are going to have as many subscribers as we want, okay? In this case, we have a subscriber, of course, a subscriber of the status, okay? Subscriber of the status. And in this case, what we have is, again, NodeRED, okay, waiting for that information and then saving it to Influx Db. Okay, this is the schema. We
have a very good question, actually, just to complement what you are saying, Oriol, that is there any particular reason that we don't write straightforward to the database and we use MQTT in the middle?
Yes.
I think this is a really good question.
The idea is when you develop any of those solutions, it's very important to decouple the the parts as much as you can, because it's nothing to do, okay, it's nothing related between the two functionalities. It's something is get the data, another stuff is what you want to do with that data. In this case, it's very simple because we just want to do one thing, which is save it to the database. But in real environments, this is not the true. So usually you want to do many more things with that data. Maybe you want to save that to the database, and in another place, maybe you want to use NodeRED for notifying to, I don't know, to WhatsApp or to Telegram, saying, hey, something's went wrong here. Okay, and at the same time, you want to maybe, I don't know what else, just send an email informing about that issue. And at the same time, I just want to save that to a database of incidents of I don't know what else, okay? So remember that if you couple the readings with the actions, you are going to have to modify a lot of stuff every time, okay? And maybe today you want to save that information to Influx Db version 1, and in some months you want to play with version 2. And you don't want to modify everything. You just want to modify the places where you play directly with the database. And this is a way to decouple the code and to allow you to deploy the events in real time to all systems of the factory. Mm-hmm. Remember, here we are talking about Industry 4.0. The main difference between Industry 3.0 and Industry 4.0 is breaking data silos. Okay, in Industry 3.0 we have a lot of data silos. If you don't understand what I am saying, it's super easy to understand. Imagine how many Excel sheets you have around your factory, your business, for running whatever. This is completely, it's a lot of silos of data updated without any kind of control, without any regularity, without any feasibility, without any reliability. Okay, so it's a nightmare. This is Industry 3.0. What we try to do in Industry 4.0 is to have a source of truth, we want to have real-time data. We have to break all those silos. We want to integrate the data with, for example, artificial intelligence models in real time, if it is possible, etc.
Yeah, imagine that you want to change your database, so you don't want to use Influx anymore. You want to use Redis time series. What do you want? What do you need to do? Well, maybe with NodeRED it's easier, right? With this example, you just add the new package. But yeah, if you have MQTT, it's so easy. You just subscribe to the topic that you want, and then it automatically works. Even if it's not on the edge, the database. Imagine that it's in the cloud. So if not, you need to couple then another database to your source code, and that's super painful, actually.
Yeah, an important thing that you said, Mark, and I want to remark it, why all that stuff, it has to be in the same system. Maybe it's a completely distributed system inside the same premises, or maybe around the world. Okay. Sorry,
we have another very good question.
Yeah, but
how to guarantee security in MQTT?
Yeah. There are many different levels of security. First of all, you can secure the channel. Later, you can create ACLs for filtering the data that it can be published and for which sources, and a long list of etc. Okay, so sorry, Cyrene, but if we have to extend all those so deep questions,
you can Google MQTT S, that it's actually TCP running on SSL, on TLS or SSL.
Or for example, HiveMQ, it's a good source of truth. Hive MQ, you are going to find a lot of information about how to play with MQTT from scratch to guru level. I don't say this is the best software. I'm just saying that you have a lot of very good information about MQTT. If you want to play with a so sophisticated system, you can play with this one, EMQX, but the most famous one is none of them. Okay, it's Mosquito. Okay,
from Eclipse. It's the one that we are running here.
Yeah. Okay.
Can we replace? So another very good question. Can we replace MQTT?
Okay. You mean if there are any alternatives? Yes. For example, AMQP. AMQP. It's one alternative. You have many more. Okay. But if we have to talk about Industry 4.0, the ideal is to use MQTT, and on top of that, we can use something called Spark plug B.
Yeah, this is kind of the standard nowadays, or what is fashionable today on Industry 4.0.
De facto standard, yeah.
Actually, it's for the paradigm of this communication protocol, the publish subscribe, which it makes very interesting. For example, if you want to change that for a REST API, it's not exactly the same because there is no publish subscribe. It's just you would need to do polling from the other side, and it's not that interesting.
If you are familiar with GraphQL, okay, GraphQL plays very good with MQTT, for example. Okay, if you don't know what I am saying, just forget it. Just for helping you if you already know something about GraphQL. Then let me go back to what we were doing here. Okay.
Yeah, feel free to keep asking questions.
Yeah, it's good. We love to receive those questions, but some of them are quite deep. Yeah, okay, we need some time for properly answering them. But yeah, as a short answer, I think what we did is good, no, Mark?
Okay,
yeah, I think
so. But I would love that. Yeah, you show me that you have a power tag. Hey, can you do like another flow to see the power attack data coming?
Yes.
Can you do
it? Yes, of course. I just want to show the Graphana.
Okay. Yeah, of course. I forgot about that.
Yeah. We created a small dashboard. Okay, let me show you, for example, last hour. Let me say just last 5 minutes. We don't have readings from live. In the left side, we created, thanks to Graphana. Remember, the information is stored in Influx Db. Now, we are going to use Graphana for extracting the data from Influx Db and pasting that data here. Remember, now, when we click, we read. So I'm going to click, and if I go to Graphana, you can notice how it says it's open, it's data from last 5 minutes, every 5 seconds, the database is queried. Okay, and then it says it's open. Let me go to
just as a sorry, just as a context, now Uriol is closing the circuit. As you can see, 1 second, NodeRED, it's on the port 80. If you can see the URL, and Graphana, it's exposed on port 3000. So if you test that, Graphana is accessible on port 3000.
Yes.
MQTT, it's on port 1883, if I'm not wrong, and Influx Db, it's on 8886, if I'm not wrong. So it's everything documented on the GitHub repository. But for the sake of explaining here,
by the way, at the same time, okay, we did that small demo, just 2 readings, okay, one from open, another one to close. I'm going to to stop the fan just for surviving. Okay, and then if I go back here and I click here for reading, it's open, and we have the reading here. Okay, just we close the loop, and now maybe it's time to show you how it's how PowerTag works. Okay. Oh, Nicolo, nice to see you here, Nicolo. I have never used Graphana, but the NodeRED dashboard, yes. What is the difference and what is the advantage of using Graphana? Wow. Nicolo is one of the students that we have in the Master of Internet of Things. And the module number 12, which is going to be given for Atif Ali. Okay, Atif Ali is a Graphana developer, which is going to teach you about how good it is, Graphana. Nothing to do between NodeRED dashboard and Graphana. What I mean is that NodeRED dashboard, it's for basic stuff. Okay, it's, let me say, a little bit configurable. Okay, but here in Graphana, you have tons of options. Just take a look on data sources. If I go to data sources and I want to add one data source, I have Prometheus, Graphite, OpenTSDB, Influx Db, Loki, Elasticsearch, Jaeger, Zipling, Tempo, MySQL, Postgres, Microsoft SQL, and maybe I can spend 2 next hours saying sources of data that you can use for free or paying in Graphana. This is one of the main advantages that you have. Okay, NodeRED cannot integrate as easy as it does different sources and mixing different sources in the same dashboard, in the same graph, in the same table. Okay, maybe in a heat map. It brings me to the second advantage, which is the types of panels that you have available. The types of panels that you have available in Graphana, maybe Graphana has, I don't know, 200 types of panels. Okay, so you have time series, bar charts, stats, gauges, bar gauges, tables, pie charts, state lines, heat maps, status history, and if you don't have what you want in that list, don't worry, you have a very long list of plugins and etc. for extending. What I mean, it is the competitor of Graphana. It is not NodeRED dashboard. It is Power BI, for example. Okay, so take that into account. Then, as Mark asked me before, the challenge is here. Okay, Mark. Yeah.
Make me happy, please.
Okay, then I'm going to look it up for a Modbus reader. Here it is. I'm going to drag it. I'm going to call it, this is just an arbitrary power tag. Whoops, not tag, just arbitrary name, as I said. Then power tag uses unit ID 150. I'm going to read the memory. I'm interested in 3059. Let me show you how I know that. If I jump here, look it up for 39. Okay. If I go to the power tag wireless communication energy sensor Modbus tables, okay, in the position 3059, I have a total active power that pass through the circuit breaker. I have to read 2 bytes, and I have to parse that information as a float 32. Okay.
Yeah. This is why you install the package, for parsing the.
Yeah, we are going to see it now. Let me say just quantity of 2. I'm going to say just 5 hours, and later I'm going to jump to seconds. I think it's mostly.
I mean, while you do this, Sean made a comment in the chat. I think not for all, but he was saying that well, I will read it in loud for the sake of the recording. But yeah, of course, the NodeRED dashboard is nice and simple, and it's enough sometimes to interact with the data that it's being managed from the NodeRED. And yeah, of course, Graphana, it's more extendable and more. We are not saying that it's bad, the NodeRED dashboard, but what we are saying is for the sake of this demo and for the extensibility that you can do in future projects, we thought that it was very interesting to add a container on the device, running Graphana on another container, and enabling you with all the connectivities from NodeRED to Influx and from Influx to Graphana, just for the sake of the demo.
Yes. Guys, I love NodeRED. Okay, I don't want to say something wrong about or bad about NodeRED. Okay, I just want to say that NodeRED, it's specialized in transforming flows of data in real time. The main purpose of NodeRED, it is not create dashboards. Okay, can you do that? Yes, you can, as you said. Correct, but it is not its main purpose. And because of that, there are other applications more focused on that stuff. Then what I did so far, it is just to create that Modbus reader, which is going to read the power tag. And I created a Modbus response node, or just drag it to that node. Now I click it and I read it. What I have here, it is 0, of course. Why? Because the circuit breaker, it's open. Okay, just if I go, okay, and I turn it on, okay, and now I come back here and just click it here. Okay, you can notice that now I have some readings. I don't know what they mean, because I didn't parse the data. The data is in X.
Exactly. You need to do the conversion from hexadecimal to float.
Yes, I have to convert that memory readings to a float 32 reading. For doing that, I'm going to use a node called buffer parser. Okay, I'm going to connect buffer parser here. And hey guys, seen this Frank Godin Fuchs. I don't know what's that. Sorry. Maybe Mark, you know.
Yeah, let me open that. Just see what is this.
Then I just have to set it up for parsing that data. The only thing that I'm saying here is the data that I'm going to receive comes from, pay attention, it says data, okay? Because it says data, oops, I have to put payload.data. Then I'm going to specify in the UI, so in the next settings, how I want to parse the data. I don't want to swap any byte. I just want to use a key value response. I have to parse a float, what is float BE. I'm going to use, for example, total power. Total power, sorry. And I'm not going to use offset and neither mask. And then let me check. Oh, sorry. I plug it here and I have to plug it here. And now what I am going to have, it is, whoops, sorry. I want to put a debug node just for checking what's coming from here. I want to configure that as a status. I'm going to say this is going to be a power tag, power debug. for example. And let me try it just in a second. Then if I click it, it says total power 0. Good. Let me turn it on again. Now I go here, then I click it here, and it says 0.103. Then it means 103 watts hour. Okay, so the reading it is in kilowatts hour. Okay, then the next step it will be just publish that to MQTT. For doing it, just go to MQTT publish. Bam. Click it here. This is the same broker. I can say IC60 and power, for example. I don't QoS 0 and retain false. And then this is just an arbitrary name. I'm going to copy the payload. Then, thanks to that, we are going to publish in MQTT the readings that I have here. Then a good idea, it will be to create something that we had here, no? Then just an MQTT reader, but in this case, I just want to read the power. Okay, and then I just want to create a functional node. Whoops, for transforming the reading, because the reading is going to come in a string. I don't want to have a string. I just want to have a float, because I want to inject that to the database. What I'm doing here is just casting the data, just for ensuring the data that I want to inject to the database is going to be a float. What I'm doing here now is just to say, please, every time that you process that, inform or tell me what was the time in the node status. And thanks to that, I can control when the data is injected in the database, the same thing that I did here. Okay? Every time that something is injected, I can see the timestamp of that injection. Then the next step, it is just to say that we want to save that to Influx Db. Influx Db, it is going to be an output. I connect that to the output, double click. Here I say just an arbitrary name, Influx Db, and the measurement is going to be, for example, power. Okay, we already configured the connection to the database, remember? Okay, I don't have to change anything here. Then done, and now I can deploy. Maybe it's a good time to say read every 5 seconds, no? For,
yeah, better, yeah.
Yeah, for
So
fastly injecting the
stuff.
stuff. Yeah, and now I'm going to say the same here. Done, deploy. Remember, the fan is spinning.
Oh, wow.
The light is on. Okay, so the data is moving around. As you can notice in the database, the data is injected just now. Okay,
you can see power is not a number.
Sorry,
you can see on the errors on the logs.
Oh yeah, unable to parse power, blah blah blah. But
value
this is
NaN, it's not a number, so maybe there is something.
I failed here with something. Let me check. Oh yeah, because of the payload. Sorry, here I forget to assign something. I'm going to use a node called switch. I'm going to put that node in the middle, and I have to say that. Sorry, I said switch. It is not, sorry, it is change. I have to change it. What I'm going to do, it is the data, as you notice here, is total, semicolon, and the information. So it is an object. And I don't want to publish the object. I want to publish just the reading. Okay? Send the payload. And then I want to say, this is payload total power. Now I deploy it. If everything is okay. Okay, now I don't have errors here. I forget to remove that. Okay, then everything is going to. Now we have readings. We go to the database and we can see the data is injected. Oh, come on. Unable to parse power value none. Okay, this is because it's empty, no? For any reason. What I made wrong here. Let me check it. Is total power? I made a mistake or not? Total power and says total power is correct.
Uriol, maybe it's message.payload.total power on that node.
I didn't say payload.
No, message dot. No, on the to the value. If you go to the value.
To the value.
Do you need to specify?
Oh yes,
MSG
sorry, sir. Yes, you are completely right.
Okay.
Thank you.
Yeah. Let's pray to the demo gods, everything.
Yes. We said that at the very beginning. Okay, now it seems no errors comes from here. Let me clean that. Just wait for the next, right? Yes, no errors. Then jump to the Graphana, and here we have some readings. Let me change the power of the fan just for taking a look here, how they change. I don't know if it is in the maximum power or minimum. Just move it. Okay, I changed the power now.
So just spinning faster now, or?
Yeah, it has to. No, it's not changing so much, no? Let me change another position.
I just put your camera so people can see you interacting with the fan.
Yeah, thank you. Okay.
Oh, sorry.
Yeah, now we changed it. Now it's 0.09. Okay. It's not, or maybe I can stop it, no?
Yeah, of course.
I just stopped the fan. If you go here, you can notice how it is stopping. Okay, and now the readings jump to 0. This is 0 because, as you already know for sure, that LED consumes close to nothing, and the power tag cannot read so small quantity of backs. Marc, do you think we have enough time for showing how we can connect that to the cloud?
Yeah, why not? Yeah, if you want to do that, maybe it's a good idea.
Okay, then we go here. Okay, and what we want to do is every reading of the power. No, we're going to use a cloud platform called the Data Cake.
Exactly, for the sake. So actually, on the master, I already used that on a session on the module 5, and well, I use it just because it's simple. But I also use other platforms like the things.io or UBDots, for example. So yeah, feel free to use any. The idea here it's that our single source of truth it's in a cloud, in a third-party cloud like DataCake, for example. And I just created a fleet called test MQTT. I created this dashboard, and basically what we need to do, if we go to configuration, maybe you don't have rights, but actually I got, I can see up here. Basically what we need to do is to connect MQTT out to this. So actually this is going to be compatible with any connections that you want to do outside of the system on another cloud. So the idea is that we need to add a new
sorry, Marc, just a second, because you are going to remove it.
Oh, sorry, yeah, I didn't click. Okay, thank you very much.
Go.
So actually this is the MQTT.
what Marc is doing now is just putting the credentials and the coordinates for connecting to the MQTT broker of that that IoT platform. Okay, when the data,
trying to copy. Can you copy the tokens that we need? Because I'm not sure how. Yeah, last time I tried to copy and paste.
Can you put it in WhatsApp, for example, and I'm going to copy them here?
I think I already shared it, but it's 2 messages away.
Oh yeah, I didn't.
Wait a sec.
Oh yeah, the C52 blah blah blah.
Or yeah, C52 indeed. Yeah.
This is the user, the user.
Yeah, because just to paste, it's Control V. Oh, yeah, exactly this one. Yeah, and just paste that as a password. So basically, you create a member on your fleet. You give API credentials, and then it gives you the. Yeah, it's. I'm gonna delete these after the. And then we have to specify the topic. If I'm not wrong.
I have it here.
Okay, you have it? Okay, fantastic.
Yes, don't worry.
So just paste it.
Yeah, this is the topic.
Instead of, in this case, it's the power. So instead of test, just call it power. Yeah. At the end of the topic, we have the field value that we are gonna. So put a slash, please. I don't see if you have a slash or not.
At the end, after the power?
No. Okay, that's correct. Sorry, I couldn't see properly. Okay, so that in theory, if we do done. That
then pay attention. Okay, that what we have here, it is when an event happens in our factory about the power consumption, that information is going to be saved in the database, and in the same time it's going to be delivered to that cloud service. Okay, maybe we can use another flow, but just to go straight to the point, we put that here. Okay, but maybe it will be better to put that in another place. By the way, if I do I deploy that, Marc?
Oh yeah, give me a sec. Yeah, but try to deploy. Let's see if it says connected.
Yeah, it says connected. Yes,
oh, that's fantastic. So
then Marc, it's going to connect. I don't know, Marc, if it makes sense to share your screen. I don't know.
No, that's okay. That's just go to dashboard. So what I did here.
Here I am.
Yeah, sure. Well, I can. Let me click on your screen.
Oh yeah, sorry, not my mistake. Move it.
So let me refresh.
No, because here it is. Yeah.
Because I was doing a test before.
Yes.
So let me refresh. So now, I just updated to power.
Yes. Okay. Let me start the fun. No.
All yours. Yeah. Well, is it sending data now, Oriol?
Yes, but it sends zeros.
Okay. Fantastic.
Now I power on the fan, and if we go to Graphana just a second, we can notice how it starts growing.
Let's see if I did the configuration or not.
And now if I go here,
maybe it's something that I did wrong. Huh? Oh.
Yeah. Maybe the topic changes. Maybe.
No, but I added the new topic, which is power. No, if I'm not wrong.
No,
look at this 009.
Yeah,
we have.
Here it is 0.09. No.
Yeah.
The same stuff that we have here 0.09. Okay. Yeah. I think we are close to the end of the session, Marc. I think the idea, it's very basic, no? It's very, let me show you the schema. Okay, what we are doing here is we are reading that power tag that we have here. The information is inside the Modbus server or Modbus master that we have in Acti9. NodeRED reads the information in the Iot Gateway, and then the information is published to the data cake MQTT broker. And thanks to that, the information is available to Graphana, and at the same time, it's available to data cake. I don't know if we go to history, if we can see.
I'm not sure why it's not.
Yeah.
Okay. Yeah. Sure.
Here it is power. Just the last update, no? I don't know
Yeah, I
if you
don't
can
know
see
why
all
we
the
don't see that
readings.
on the dashboard, but yeah, probably.
We see here there are different readings.
Yeah.
By the way, the idea is already explained, no?
I think so. So what we explained today is, yeah, how to get into an infrastructure that it's running on Modbus, how to deploy with open source technologies in a really fast time. Actually, maybe it's extra 20 minutes to deploy everything on an x86 machine. And you're going to deploy different services, NodeRED, MQTT broker, Influx Db database, and Graphana. And yeah, with some simple flows that are actually on the local memory of your NodeRED, actually, yeah, you will be able to run something like Uriol show. Yeah, if you use a different machine, yeah, go to the manual and go to the table with all the addresses and all the information just to change that. But just this is an example of how can you digitalize a legacy system using Modbus with a gateway.
It could seem something stupid, but we repeat that many times at the end of the year. So it's something that happens very often. Marta is here. Yeah.
Oh, okay.
Mark, yeah, tell me.
I don't know if you want to, probably it's not a 5 minutes answer question, but yeah, just to talk about a little bit about the TCP security on the.
Oh yeah, just fastly. Yeah.
Mm-hmm.
Remember, it's let me say, I don't want to say mandatory, but close to mandatory, to try to isolate Modbus TCP devices in their networks. So don't share TCP IP addresses with the rest of the devices of the factory, and try to create isolated networks. For example, in this case, as you notice here, the network of the factory is 10.2.0.0 type C. And the network of Modbus master, it is 10.46.1.0 type C. So it is a completely different network, completely unroutable network. No one can access there. Why? Because Modbus, it's impossible to protect it if you don't isolate it inside the TCP IP network. Because of that, if you have to start a project from scratch nowadays, please forget to use Modbus, because in my current job, usually I find people designing solutions today using Modbus. So you can use other stuff like I don't know, OPC UA or other protocols, but don't use Modbus nowadays. And if you have to connect legacy, you know how to do it today. So Marta, please, it's your turn. And thank you, everyone.
Thank you, Uriol and Marc. This was very interesting, and I think people enjoyed it very much. If you have further questions, you can leave them here and we can give you answers as well. And now I'm going to share the presentation.
Let me stop sharing, Marta. Sorry, my mistake.
I think there's no problem. I can do it anyways. Yes.
Okay.
So basically what you have seen here, it's an example of what you will find in the Masters of IoT, which Uriol is director and Marc is professor. And basically, for you to get an idea, with this Masters, you will get 4 blocks. And on the first block, you will dig into the business models. You will understand the project management within IoT projects. The second block, you will look at the different architectures and also on the cybersecurity aspect of it. The third one will be more about edge and fog computing and all the different protocols and connectivity that there is. And also you will go into the cybersecurity of those aspects. And the last one, you will look at the cloud and visualization analytics, which is a little bit of what we have seen today. And at the end, it's very important that you can bring your own project and you can actually develop it through your master thesis. And you will obviously get all the expertise from all the teachers that we have, which are, some of them are teachers, but most of them, they're industry experts. So they have actually worked every day for many years with all these type of projects. And if you would like to have more information, you can grab your phones and scan these QR codes. and it will direct you to the website in which you can ask for further information about this. And the last thing that I told you is that I have a small surprise, and that is a rooftop course. So this is an online platform that we have developed, and this is all short courses on many different topics. And here there's an example of an IoT lab topic. We will be launching new courses on IoT as well. Some of them more techy and some other ones more focused on industrial IoT. This one that we have is more on the business side. And you can, again, grab your phones, scan the QR code. It will direct you to the Rooftop website. And then once you choose the course and you put it onto the basket, you can put in the the code, which is WShopIoT22, and then you will get the course for free. So I hope that you enjoyed it and that you felt that this was useful for you. You have further questions? Okay, I see you do. Let me have a look. Okay, so thank you very much.
Yeah, just let me say something, Marta. Someone said we made some errors talking about bytes and bytes per hour, blah, blah, blah. So sorry, my mistake. I apologize. So sorry. You know, a lot of stuff to prepare, and sometimes you make those small mistakes and you don't pay attention. So thank you for your understanding.
That's good. All right, so that's everything. Thank you very much all for being here. Oriol, Marc, it was a pleasure to have you here. All this session has been recorded, so I will share it with you as well, so you can look into it. And I hope you have a nice evening.
Fantastic. Have a good day.
Take
Bye.
care.
Bye.
Bye-bye.